In this slide we're going to talk about multiplying and dividing powers. Here we have two rules. We have the product rule and we have the quotient rule. The product rule is when we're multiplying, and the quotient rule will be when we're dividing. So the product rule states when we are multiplying two powers and we have the same base, then we can just add the exponents together. So let's see how this works. 3 to the power of 2 times 3 to the power of 4, we're multiplying, so we can use the product rule. The bases are both 3, so the rule says we can just add the exponents together. Why does it work? 3 to the power of 2 means 3 times 3. 3 to the power of 4 means 3 times 3 times 3 times 3. And since we're multiplying them together, it essentially means 3 multiplied by itself 6 times. So we could write it out this way, or we could realize we just added the exponents, as in this case. So 3 to the power of 2 multiplied by 3 to the power of 3, because the bases are the same, and that's key, these bases must be the same. If these bases are not the same, this rule does not apply. We can add the exponents together to get 3 to the power of 6. Note, we're allowed to keep our answer in exponential form unless they ask for standard form. Exponential form is when you have an exponent. Standard form would be the standard answer. So now let's look at this example. 4 to the power of 3 multiplied by 4 to the power of 4. We're multiplying. The bases are the same, so the product rule says when the bases are the same and we're multiplying, we can add the exponents. So 4, 3 plus 4 is 4 to the power of 7, and that's exponential form. If I wanted standard form, which is the answer, I could figure out what 4 multiplied by 4 times 4 times 4 times 4 times 4 times 4 is. We do that 7 times. We get 16,384. On this side, it's the same idea, but what I did here is I converted to standard form first. So 4 to the power of 3 is 4 times 4, which is 16, times 4, which is 64. I'm going to multiply that by 4 times 4 times 4 times 4, which is 256. And I multiply these together, I get 16,384. Either way, you get the same answer. If they want you to leave it in exponential form, this is the easiest way. If they want you to leave it in standard form, this might be the easy way. Whatever they ask you for, you're going to have to do what we are most comfortable with. Remember, you have to have the same bases and you have to be multiplying in order to add these exponents. This law only works for multiplication. It does not work for adding, it does not work for subtraction, and it does not work for division. Just multiplication. Now let's talk about dividing powers. Dividing powers is the quotient rule. The quotient is the answer of a division question. The quotient rule states when we're dividing two powers, and again, the same base is needed, we can just subtract. So here, when we're multiplying, we added, and now we're dividing, we can subtract. Why does it work? 2 to the power of 5 divided by 2 to the power of 3. Bases are the same. That's essential. Bases are the same. We're dividing. If I wrote this out in standard form, 2 to the power of 5 means 2 times 2 times 2 times 2 times 2. And I'm going to divide 2 to the power of 3, 2 times 2 times 2. These will cancel out. 2 divided by 2 is 1. This 2 divided by 2 is 1. This 2 divided by 2 is 1. So essentially they're canceling each other out. And I'm left with 2 to the power of 2 on top, which gives me 4 as a standard answer. Again, exponential form, standard form. Or we can use the quotient rule. 2 to the power of 5 divided by 2 to the power of 3. When the bases are the same, we can subtract the exponents. So 5 minus 3, which is 2 to the power of 2, which is 4. Now this example may be misleading. Some people think we go 2 times 2 to get 4, but we're multiplying the base and the exponent. That is not what we're doing. It just happens to be an example like that. For example, if we were here, just like in here, I'm not going 2 times 5. I'm going 2 times 2 times 2 times 2 times 2, 5 times. When you get questions like this and examples, people sometimes get confused. Make sure this means 2 multiplied by itself twice. Again, this is left in standard form. This is left in exponential form. We'll look at a couple examples here. 3 to the power of 8 multiplied by 3 to the power of 4. Bases are the same and I'm multiplying. This is the product rule. The rule says when the bases are the same and I'm multiplying, I can add the exponents to get 3 to the power of 12. And I'm going to leave this in exponential form. B. 4 to the power of 6 divided by 4. Now 4 is the same as 4 to the power of 1, but they don't show it. You don't have to show it, but it's there. Bases are both 4, so the quotient rule says when the bases are the same and I'm dividing, see this little line here? Kind of looks like a minus sign. I'm going to be subtracting these. So I go 6 minus 1, which is 4 to the power of 5, and I will leave it in exponential form. And then our last question, we have a division or multiplication question and a division question. The bases are all negative 2. So when the bases are the same, I can add the exponents, 3 plus 4. And when the bases are the same, I can subtract the exponents. So 3 plus 4 minus 2, which gives me negative 2 in brackets to the power of 5. When I'm leaving this in exponential form, I'm going to leave the brackets every time I can. Whenever you can leave the brackets, you probably should. Last question, and we'll look at second last question. 5 to the power of, or 10 to the power of 5 times 10 to the power of 4 minus 10 to the power of 3. Again, subtraction. There are no rules for adding and subtracting. We're going to have to go standard form here, which you'll see down here. But there's a rule here because I'm multiplying. So when I'm multiplying and the bases are the same, add the exponents. So you get 10 to the power of 9 minus 10 to the power of 3. Again, no rule for subtraction, so I will figure out what 10 to the power of 9 is, which is a 1 and 9 zeros, minus 10 to the power of 3, which is a 1 and 3 zeros. When I subtract these, I get 999,999. And then our last one, it looks quite confusing, but look at this. I have a division question, a subtraction question, and a division question. BEDMAS says I must deal with the exponents and division first, and then deal with this subtraction last. So as you see all the way down, the very last thing I did was subtraction. So now I look up here, I'm dividing, and the bases are the same. Bases are both negative 3. Bases are the same. I can subtract the exponents because I'm dividing. That's the quotient rule. So I figure out negative 3 in brackets to the power of 1. 6 minus 5 is 1. Over here, bases are the same and I'm dividing, so I'm going to subtract these. Negative 3 to the power of 5 minus 3, which is 2. And back over here, negative 3 to the power of 1 is just negative 3. This minus sign and this minus sign. Negative 3 squared means negative 3 times negative 3, which is a positive 9. And the rules of integers say that when I'm subtracting, I will rewrite this as an addition statement. So in my head I'm thinking negative 3 plus a negative 9. And the answer here is going to be a negative 12. If this part's confusing, you're going to have to go back to the rules of integers and relearn your rules of subtracting integers. But again, what I did, I don't subtract integers. I change this to a positive, and I change this to its opposite. So this would be written as -3 plus a -9. The signs will be the same now, so I keep the sign on and I add the numbers. So that's multiplying and dividing of powers.